Welcome to this class. Today we will be talking about solving the problems related to speed. Now when we solve problems related to speed, they are divided into various types like problems related to train, problems on boat, and all these fall under the category of solving problems which deal with relative speed. Now to start with, let's understand what is speed. If in simple terms I say speed is the distance covered per unit of time. Now if I say I am traveling on a road and I am covering a distance of 100 kilometers in 2 hours, that means in 1 hour I would be covering a distance of 50 kilometers. So I can say my speed is 50 kilometers per hour. Now whenever we are solving problems related to speed, it's very important that we pay attention to the units first of all. So the most common units that we talk about are either kilometer per hour or meter per second. If I try to convert this unit of kilometer per hour into meter per second, I can say it's 50 into, if I convert kilometers into meters, it would be 1000, and hour into minutes, that's 60, and minutes into seconds, that's again 60. So 60 into 60, so that would be 6 into 6. So if I cancel this, so that's 5 by 18. So if I convert kilometer per hour into meter per second, I can say it's 5 by 18 meter per second. So if I have any value, say 50 kilometers per hour, I want to convert it into meter per second, I can directly use the formula 50 into 5 by 18, and that would give me 100 by 18 meter per second. Sorry, not 100, 250 by 18 meter per second. Now that is when I am trying to convert kilometer per hour to meter per second. There can be another case when I am trying to convert meter per second to kilometer per hour. So I can just use inverse of it, that is 18 by 5. So any number if I multiply by 18 by 5, it would give me kilometer per hour. So this is a simple demonstration of solving the units from kilometer per hour to meter per second. Now there can be examples where units is used in meter per minutes. So it's important to read the units again here and convert the respective unit either into hour or into second, or based on the choices that are given in the question. Might be there is a choice that is mentioned in minutes, so you need to keep the unit in minutes. Now whenever we talk about solving distance, as we said, speed is equal to distance by time. So we must first calculate distance. Now when we would be talking about problems related to train, what we would be doing in today's class. So our focus in today's class would be solving problems related to trains. And in this type of problems, the first thing that we would be discussing is the distance. We would be covering 4 aspects to study this. The first aspect is when the train is crossing, train of length L. So let's first introduce the variables that we would be using. The length of the train would be L. The length of the platform would be P. Time would be mentioned in T1 and T2 seconds. Now we are first taking a case where the length of the train is L. It is crossing a stationary pole or a tree or a man who is standing there. That's the first case we would be discussing. In second case, we would be talking where a train of length L is crossing a platform of length P. The next case, when the 2 trains are going in same direction, and when the 2 trains run in opposite direction. So in either case, we would be first calculating the total distance covered. Now to start with, let's take the first case, that is a train of length L. As we can see in the picture here, this is a train of length L. It's crossing a stationary pole. It can be pole, it can be tree, it can be a man standing there. Now what is happening? As we can see in the first figure, this is the length of the train, this is the pole. Now the train starts to move, and as we can see in the next picture, the train has crossed it. The engine is here and the tail of the train is here. So we can say the distance covered is the length of the train in this case. So when you have the length, the train of length L, which is crossing a pole, a stationary object, or a man or a tree, the total distance covered would be L. That's the length of the train itself. Now let's take the second example where the train of length L is crossing a platform P. So you have, this is the platform and this is the train. So now the train has started from this point. So that's the length L of the train. This is the length of the platform, that's P. Now what happens is, the engine of the train is just at the starting of the platform. Now as you can see, the train has reached the end of the platform, so it has covered whole of the platform. And now in the last figure you will see the train has moved and the tail of the train is touching the platform. So this is again the length. So in this case we can say the total distance covered is equal to the length of the platform and the length of the train. So the total distance here would be length of the platform plus length of the train. So that's L plus P. Now when I have two trains, let the length of the two trains will be L1 and L2. Now what would happen in this case? Consider this, that I have two trains. One is a yellow train and another is a red train of different lengths. Now as I see, both of them are going in the same direction. So this circle denotes the engine of the train and this end denotes the tail of the train. Now as you can see, both of the train are starting here. Okay, they are running into a same direction. Now this train goes ahead at a faster pace as compared to this train. And at a point you can see the tail of this train and the engine of this train are in an alignment or in one line, and this, as you can see, would cover the total distance. So we can say length of the train L1 plus length of the train L2 would be the total distance covered. So when they are moving in same direction, we can say L1 plus L2 would be the total distance covered for both of the trains. And now let's take the last example to understand the distance. So you have two trains that are running in opposite direction. So this is one train and this is another train. The engines of the train are coming in one direction. Now this train, which is red color, reaches the engine of the yellow train and slowly goes across, and then you have the tails that align into a common line. So you can say that it would lie here first and then it would be at this position. So the total distance covered would be the length of yellow train plus length of red train, which we have denoted by L1 plus L2 again. So again in this case it would be the length of the two trains. So irrespective of whether the trains are moving in same direction or trains are moving in opposite direction, the total distance covered would be the length of both the trains together. Now we have already talked about distance. In the next section we would be talking about speed. So let's first solve a very simple problem that is based on distance. Now in this question, as you can see, I have a problem that shows a train passes a stationary man in t seconds. Now we already know the formula for speed. The formula for speed is distance upon time. Now the train passes a stationary man in t1 seconds. We have assumed the length of the train as L. So let's say L by t1 would be the first case. And in the next case, it passes a platform or a bridge and the length of which is P. So we have assumed the length of platform as P. So in this case, it would be L plus P would be the total distance, and that it is completing in t2 seconds. Now if I try to solve this question, I can get the length of the train. So I have LT2 is equal to LT1 plus PT1. Now I solve it. LT2, I bring it this side, T2 minus T1 is equal to PT1. So I can say length of the train is the length of the platform into time taken by the time taken to cross the stationary object or the stationary man, and next is the difference in the time between the two objects. Now let's solve a simple question based on this. So let's say the length of the train is 50 kilometers. The length of the train is 50 meters. It crosses a stationary man, say, in 5 seconds. The platform, the length is 100 meters and it crosses the platform in, say, 15 seconds. Now I want to calculate the length of the train that is unknown here. I want to calculate it. Okay. So length of the train which is not known, say L, divided by the time taken to cross the stationary object is 5. Now in the second case, the length of the train plus the length of the platform, that's 100 meters, and the time taken to cross it is 15 seconds. So if I solve this, I get 15L is equal to 5L plus 500. So you have 10L is equal to 500. So L is equal to 500 by 10, that's 50. So I can say the length of the train in this case would be 50 meters. So that was a simple numerical to calculate the length of the train. If you consider, because I have considered the speed as equal in both the cases, because the same train is going, there is nowhere mentioned that the train changes its speed. So we can say in the first case and the second case the speed is equal, and we can equate these two formulas. So with this we understand how to calculate the length, the total distance covered, and also we have got an idea to find the length of the train if other variables are known. Now in the next section that we would be covering, we would be talking about the concept of relative speed. Now when we talk about relative speed, we would take two cases. First is the two trains moving in the same direction, and the next case is two trains moving in the opposite direction. Now let's first understand what is relative speed. Relative speed is the difference in the speed of two trains or two objects, and we can say relative speed is equal to relative distance by time. So let's first understand what is the relative distance in the first case. In the first case, we can see the engine of both the trains is facing this side. So we can say we are considering the first example, that is both the trains are moving in the same direction. Now what will happen when both the trains are moving in the same direction? In the first case, which we can see here, let's assume this at an interval of 10. Okay, so you have 10, 20, 30, 40, 50. So you have 0, 50, 100 and 150 as the marks on the scale. Now try to understand, when they are moving in the same direction, they are originating at the same position. So there is no relative distance between the train. In the next figure, you can see this train is at point 150 and the engine of this train is at point 100. So the relative distance between them is 50. So that's the difference of 150 and 100 would be the relative distance or the distance between the two trains. And this relative distance will help us find the relative speed. So let me move back. So just coming back to the first slide, you have two trains starting at the same origin. Now this train is moving at a say speed of 100 meters per second, 100 kilometers per hour. Okay, and this train is moving at a speed of 50 kilometers per hour. So what would happen after 1 hour? This train would cover section of 100 kilometers, so that's from 50 to 150. So as you can see in this slide, this train has jumped from 50 to 150, moved 100 kilometers, while this train is at a speed of 50 kilometers per hour. So it has moved from 50 to 100, that is a difference of 50 here. Now since both of the trains are going in same direction, you can see the difference here. This train is at a point of 150 and this train is at mark of 100. So I can say that the relative speed is S1 minus S2. So speed of the first train minus speed of the second train. So the speed of the first train here would be 100 and the speed of the second train is 50. So the difference is 50, or I can say the locations here. So this is the point where the first train starts and this is the point where the second train is, and this is the difference between the speed. So that's 150 minus 100, or that's 50 again. So you have the difference in the speed, or the relative speed, I can say here would be 50 in this case. Now if the question is asked, what is the time taken for the train to cross one another or to overtake one another, how will you solve this? In this case, if I have the speed of the first train as 100, I have the speed of the second train as 50 km per hour. Okay, I have the length of the train and the length of the trains. So say this train has a length of 1 kilometer and this train has a length of 2 kilometers. I can say time taken for the train to cross, the faster train to cross the slower train would be here. The total speed is equal to distance upon time. So time is equal to distance by speed. So time distance would be the length of the two trains, that's 1 plus 2, and speed would be the difference in the relative speeds, that's 100 minus 50. So that would be 3 by 50. Okay, so that would be the total distance, the total time taken for the faster train to cross the slower train. So this was the case when we were discussing when the two trains are moving into same direction. Now let's take another example. In this example, the two trains are moving into opposite direction. Now when we are trying to calculate the relative speed of the trains when they are moving into opposite direction, we will again find the relative distance by the time taken, that would be the relative speed. Now as you can see, we have the same markings 0, 50, 100 and 150 kilometers. The two trains are at the origin point here. So the distance between the two trains is 150, and when they are coming from the opposite direction, they are crossing one another over this point, and here the relative distance between the train is 0. So there is no relative distance, they are just lying nearby, they are just about to cross one another, so there is no relative distance. So in this case, what would be the relative distance? So here the distance is 150, in the next case there is no distance, they are lying just on one overhead the other. So here the relative distance would be 150, because here we have 150 and there is 0. So the relative distance is 150. Now let's understand the same thing for relative speed. So when the two trains are trying to cross one another from opposite direction, what is happening? Let's say this train is again moving at a speed of 50 kilometers per hour and this train is moving at a speed of 100 kilometers per hour. So what would happen is, after 1 hour, this train would move 50 kilometers, that is it would be at this point, and after 1 hour this would move 100 kilometers, so this would be at this point. So the relative speed would be S1 plus S2 in this case, so that is 50 plus 100, that would be 150. So the relative speed here would be 150, and again I have say this is 1 kilometer long and this is 2 kilometer long, the same as the prior case. The time taken to cross both the trains would be L1 plus L2, that's the total distance, divided by the relative speed. So I have 1 plus 2, that's 3, divided by 100 plus 50. So I have 3 by 150. I can say 1 by 50 hours would be the time taken for the train to cross each other. So this was the second case where we talked about understanding the relative speed. Now to summarize with what we have covered so far, we have talked about finding the length. So when any train of length L is crossing a stationary object, the total distance covered would be equal to the length of the train. When the train is crossing a platform of length P, the total distance covered would be L plus P. When the two trains are moving in same direction, the total distance covered would be equal to the length of both trains. When the two trains are moving in opposite direction, the total distance covered would again be the length of two trains. This is the first thing that we have tried to understand in this class. The second thing is the relative speed. So relative speed is equal to relative distance by time. In the first case, when the two trains are moving into the same direction, the relative speed would be S1 minus S2, that we have proved from the diagram before. And in the case when the two trains are moving in opposite direction, the relative speed would be S1 plus S2. So these are the basic things that you must remember. Now in the previous question that we have done, we have tried to find out the length of the train when the various parameters of the length of the platform and the time taken to cross the platform and the tree is given. Now in this question, we would be finding out the speed of the faster train and the slower train. So we have a question here. There are two trains of length L1 and M2 respectively, L1 and L2 meters respectively. They run on parallel lines. When running in the same direction, the faster train passes the slower train in t1 seconds. So when they are running in same direction, I need to find out the speed first of all. So speed is equal to distance by time. Okay. So distance here would be L1 plus L2. Time taken is t1. And the speed in this case would be, when they are moving in the same direction, it would be S1 minus S2. And when they are moving in opposite direction, the time taken is t2. So I have other formula. The length of the two trains by time taken to cross it is equal to S1 plus S2. That's the relative speed. So this happens when the trains are moving in same direction, and this happens when the trains are moving in opposite direction. Now let's understand how we will solve this. We have to find out the speed of the faster train and the slower train. So we have the two equations here. What I can do is, I can just cancel out S2 and S2. I can say 2S1 is equal to sum of these. So L1 plus L2 by T1 plus L1 plus L2 by T2 is equal to 2S1. I take 2 down, so it's 1 by 2 T1, 1 by 2. Okay, so you have L1 plus L2 by T1 plus L1 by L2 by T2, that would be equal to S1. So I can get the value for S1 and then I can calculate the value for S2. That's the speed of the slower train and the faster train. Now if I have a numerical based on this value, I can say I have the length of two trains, say as 100 meters and 200 meters. When they are moving into same direction, they cross each other in say time 10 seconds. When they are moving in opposite direction, they cross each other in say time 20 seconds. What is the speed of the faster train and the slower train? If I have that data and I try to solve this, I can say in the first case, when they are moving in the same direction, it would be 100 plus 200 divided by 10 is equal to S1 minus S2. In the second case, it would be 100 plus 200 divided by 20 seconds, that's the time for the second train, and S1 plus S2. So if I calculate this, it would be 300 by 10. So it would be 30, and this would be again 300 by 20. So it would be 15. So I cancel it out. I can say S1 is equal to 15. So the speed of the slower train is 15. If I put 15 here and you have 30 here, I can calculate the speed of the other train. Okay. So with this, you can solve the speed. You can solve the questions related to speed of the slower train and the faster train. Now there are few things that we must keep in mind while solving problems related to train. First of all, what I mentioned in the starting of the class, you must be sure about the units, whether it's kilometer per hour or meter per second, or whether the choices are given in say hours, minutes or seconds, kilometers or meters. The next is, you must be sure whether you are trying to find out the length or the speed. In either case, you must know the formula, speed is equal to distance by time. So whatever is asked, you can just substitute here and you can find it out. The next thing here is, you must be sure about the choices that are given in the question. There can be choices like data is inadequate, or choices like none of these, all of these. So none of these, all of these are usually given to confuse students in these kind of questions. There can be another choice that says cannot be determined. So you must be very particular what kind of question you are trying to solve. Many of the students are just afraid of the problems related to train. So specifically for those students, it's very important to understand that here we have tried to summarize the whole concept of trains into two basic concepts. First is finding the length. That has been one of the most challenging parts for most of the students. And the next is finding the relative speed in case whether the trains are moving in same direction or opposite direction. So these two concepts, finding the length and the relative speed, are very important. So again, when we are finding the relative speed, if they are going in same direction, as we have tried to solve, tried to demonstrate it with the animation there, when they are going in same direction, it's difference in the relative distance that decreases. So it's S1 minus S2. When they are trying to go into opposite direction, we have seen the total relative distance is more. So it's S1 plus S2. I'll just move back once again. So this is the case where the two trains are moving in opposite direction. So when they are moving in opposite direction, initially they have a relative distance of 150 kilometers, because one train is here and both the trains are on the opposite end. And in the next slide we can say there is no relative distance. So there is no distance. So the relative distance from the first case to the second case would be 150 minus 0. So the relative distance here would be 150, and therefore we can say relative speed is also 150, and that we can say if this is moving at a speed of 50 kilometers per hour and this train is moving at a speed of 100 kilometers per hour, I can say it's the relative speed is the addition of the two speeds, that's S1 plus S2, when the trains move in opposite direction. So this was the basic essence of solving the problems related to train. We would be covering further problems on relative speed and problems related to upstream and downstream boards in the next